All right, let's take a trip. We're heading way out to the edge of our solar system, to a world that's dark, freezing cold, and, believe it or not, supersonic. We're talking about the ice giant Neptune. So, how do you find a planet you can't even see? That's the big question here, right? And it gets to the heart of what makes Neptune's story so cool. It's the only planet in our entire solar system that was discovered not by someone peering through a telescope, but with math, just pure mathematics. Yeah, so how on earth does that even work? It's this incredible story of how astronomers basically knew a giant planet had to be out there, lurking in the dark, long before anyone ever actually saw it. Okay, so back in the early 1800s, astronomers were tracking Uranus, and they noticed something weird. Its orbit was just a little bit wobbly. It wasn't quite where their calculations said it should be. Something was pulling on it, disturbing its path. And the only thing that could do that was the gravity of another massive and totally unseen planet. And this is where it gets amazing. A French mathematician, Urbain Le Verrier, he sat down and just crunched the numbers. He calculated exactly where this phantom planet had to be. He sent his predictions off to the Berlin Observatory, and get this, on the very first night they looked, an astronomer named Johann Galle pointed his telescope right where Leverrier said to, and there it was, Neptune, found within an hour. Just incredible. Okay, so we found it with math, but what is this place actually like? Let's take that same 4.5 billion kilometer trip that the Voyager 2 spacecraft did and see what this mysterious blue giant is all about. Wow, the first thing you'd feel, you wouldn't feel anything for long, is the cold. It is unbelievably, unimaginably cold. We're talking an average temperature of minus 201 degrees Celsius. That makes it the second coldest planet in our solar system, a true ice giant. And because it's so far away from the sun, its orbit is just huge. One single year on Neptune, that'll take you 165 Earth years. Can you imagine that? That means a single season, just one season, lasts for more than 40 of our years. And let's be clear, this planet is an absolute monster compared to Earth. It's almost 4 times wider. You could cram nearly 60 Earths inside of it. And here's a fun fact. Even though we call it an ice giant, it's actually the densest of all the giant planets out there. Think about how far away it is. It's 30 times farther from the sun than we are. So what does that mean for daylight? Well, it's basically always twilight. The midday sun on Neptune would look like a very dim dusk to us. The sunlight is about 900 times fainter than what we're used to. So you've got this dark, freezing cold world. It must be pretty quiet, right? Nope, not even close. Despite the cold and the dark, Neptune is a place of incredible, non-stop violence. It's home to the most extreme weather in the entire solar system. Okay, get ready for this number. The winds on Neptune can scream at over 2,000 kilometers per hour. That is not just fast, that's faster than the speed of sound. Supersonic. These are hands down the fastest winds ever recorded on any planet, just whipping these clouds of frozen methane all over the place. And just to put that into perspective for you, you know Jupiter's Great Red Spot, that famous storm that's bigger than our entire planet? The winds in there are 3 times slower than on Neptune. This planet's atmosphere is just pure supersonic chaos. Here's a great example. When Voyager 2 flew past, it snapped pictures of this huge storm. They called it the Great Dark Spot, big enough to swallow the Earth. But then, just a few years later, when the Hubble telescope took a look, poof, it was gone. These massive storms just appear and disappear. It just goes to show you how incredibly wild and dynamic that atmosphere is. So the weather is nuts, but believe me, the weirdness does not stop there. As we pull back and look at the whole system around Neptune, it's just one puzzle after another. Okay, for starters, its magnetic field is, it's a mess. It's tilted by a crazy 47 degrees compared to the way the planet spins. Imagine the Earth's North Pole being somewhere down in, Florida. It's that off. And it means the whole magnetic field just wobbles and tumbles all over the place with every single rotation. It's a mystery scientists are still scratching their heads over. And then there are the rings. Now, don't picture Saturn's big, beautiful rings. Neptune's are faint, they're dark, and they have these really strange features called arcs.
They're basically these brighter, clumpy bits of dust in the outermost ring that just stay together. They should spread out, but they don't. The best guess is that the gravity of a little nearby moon, Galatea, is kind of shepherding them and holding them in place.
All right, for our last stop, we're going to what might be the most fascinating part of this whole system, Neptune's biggest moon. It's a captured rebel from the edge of the solar system, and its name is Triton. So why is Triton so interesting? Well, it all comes down to this one simple question that unlocks its entire story. Why does it orbit Neptune backwards? It's the only large moon in the whole solar system that goes the wrong way around its planet. That backward orbit, what scientists call a retrograde orbit, is our biggest clue. It tells us that Triton wasn't formed with Neptune. No way. It was a loner, a dwarf planet, probably a lot like Pluto, that just wandered too close one day and got snagged by Neptune's massive gravity. And this captured world is amazing. It's even colder than Neptune itself, but it's alive, geologically speaking anyway. It has active ice volcanoes, cryovolcanoes, that shoot plumes of liquid nitrogen and dust miles high. And its surface has this bizarre texture that scientists literally call cantaloupe terrain because, well, that's what it looks like. We haven't seen anything like it anywhere else. So here's the final incredible takeaway. Triton is on a death spiral. Because of that backward orbit, Neptune's gravity is slowly, relentlessly pulling it in. In the distant future, we're talking about 3.6 billion years from now, it's going to get too close, Neptune will tear it to pieces, and those pieces will form a magnificent, brand new set of rings way brighter than Saturn's. It's going to be a beautiful, violent end for this captured, rebellious moon.